Hello, my gorgeous friends. You're welcome to the part 2 of building REST API using Golang standard library. In this section, we'll connect to the PostgreSQL database. Without further ado, let's get right into it. I'll head over to my terminal and I've highlighted a number of things that we'll be doing in this section. We'll install the SQLC and Postgres. We'll also install the lib PostgreSQL package. We'll create our models. We configure the SQLC and do migrations manually. To install Postgres, we can head over to the official website, postgresql.org, and if you click on the download, you'll see the instruction to download for different operating systems for Linux, for macOS, for Windows, and so on. For Linux, you can also see for your distribution. We have for Debian, we have for the Red Hat, and so on. I also prepared an article if you want to install it in your WSL. So I'll leave the link in the comment section. So let's head over to our terminal again. I'll go back to my terminal, open my terminal, and to confirm if you have Postgres installed, you can do Postgres -version. Then you see this version. The next thing to do is to install the SQLC. We'll head over to the official website, sqlc.dev. This tool helps us to compile SQL query to type save code. I'll click on the button and I'll click on install. Then you can install with this command for macOS, Ubuntu, and whatnot. So I'll pick this. I'll use the golang install command. Go back to my terminal and paste this here. Now that we have installed SQLC, I'll clear the screen and I'll type SQLC -version. So SQLC that's the version. Then we have the version 1.28.0. The next thing to do is to create a db config. I'll open my Explorer and create a new folder. I'll call it db config and a file called dbconfig.go. Close this, and this is going to be a package of dbconfig. I'll come down here and create connect db. This will take in a database URL. If you remember, in our last lesson we created a database URL, and this will return a pointer sql.db like so. We have a pointer here so that we can reuse the db instance globally in our project. Now we need to open our database and connect using our driver. We have not installed our Postgres driver yet, but let's create the variable db, and it also return an error. You can do sql.open. So this method opens a database specified by its database driver that we'll be installing very soon. So I'll pass my driver as Postgres. So let's bring in our driver. I'll add this, and I'll use this blank import. github.com lib then pq like so. Then you can close this. This underscore that we have here is called a blank import, and it will invoke an init function in the project. If you don't have it here, it will not work as expected. So I'll save this, and we need to install this package. So the two ways that you can install is to open your terminal and type go get, then you type the name of the package, or you can type the package first, then you do go mod tidy like so. So it will look for the package and install it. And the error is gone. We can undo the error now. We can do if error does not equal to new. You can do log.filter failed to connect to db. Then you can also pass the error like so. Then if no error, we can ping the DB do db.ping. Ping will verify if a connection to the database is still alive. Then error does not equal to new. You can log .filter f database connection failed. Then we can pass the error like so, and at the end let's just do fmt.println. I have connected to DB, and we need to return the DB instance. So scroll up a bit and return DB like so. So we have our database configuration now, and I'll go to the main.go so that we can call it from here. So I'll create a comment and I'll type connect to DB. Then we say DB should be equal to db-config module dot connect DB. The connect DB is expecting an argument, so we need to pass in our config. Do config dot database URL. Remember, we created this in the last lesson, like so. Then we need to close the function when it is no longer in use. I will come down here and write defer. Defer means it should happen after everything else. Then db.close like so. Save my file. Then the last thing to do is to create a new database. Let's create a new database. I open my terminal and type PSQL, my username. I put cyborg, then Postgres like so. Then I can create database. I'll call it REST API like so. So we've created a new database called REST API. If you type \L to list all database that we have here, if I zoom out a bit, you'll see REST API. Then let's close this. Then we can close our PostgreSQL and our terminal. The next thing to do is to create our models. Models are the shape of the data that we want to put into our database. So I'll open my Explorer again. I'll close this, create a new folder called models. Right. And the first model will be user.go. I'll call the package models. Then we can create a struct of user, call it struct. Then the user should have an ID, JSON. We have this JSON here so that we can convert the field in this struct, which is capital ID, to this lowercase ID in the output. So when we are calling from either our REST client like Postman, so we have this representation which is in capital letter converted to this JSON format, the ID in lowercase. Let me zoom in a bit. The next field is username. So username should be of type string. Again, we have the JSON, call it username in lowercase, email, string, JSON, we have it as email. Then the password should also be of type string, JSON, password. Then the date created can be of string too. I have a JSON, call it created. And lastly, we have a updated string, JSON, updated, like so. Let's create another model called blogs so that we can reference the user ID in the blog model. I'll call this blog.go. Again, package models. Then let's type our struct. call it blog struct. By the way, we have this naming capitalized because we want to make it a public struct so that we can use it in other folders and files. So we have ID of integer 2. Just we call this ID. A block should have a title. Just call this title. You have a content string. Just call this content. We have the user ID. User ID should be of int. Just you can use user underscore ID, and created should be of string. Just call this created, and lastly we have the updated string. Just updated, like so. So I'll save everything, and we have our struct nicely formatted. Now that we have created the shape of the data that we want to pass to the database, we need to use SQLC to convert our native SQL queries into type-safe code. If you head over to the SQLC official page, let me go back to the home page. We have that SQLC looks for either a SQL YAML file or a JSON file in a current directory. So we'll need to configure our SQLC YAML file to be able to convert our native queries to type-safe code. I'll head over to my terminal, and in the root folder, I'll create a new file called sqlc.yaml, and I will enter the configuration. Version is 2, then SQL. The engine will be PostgreSQL. If you're using MySQL, you can change it to that. Type queries. I'll put it in my internal. Migrations, then queries.sql. We'll create this folder in a bit, and this file. And for the schema, put it in the internal. Also migrations, then schema.sql. We'll also create this in a bit. Then we can generate, type in go, and the package should be called store. So what I'm just writing here is coming from the official document. You can read through the out directory, so where we want to store our converted code. internal.store/store, then emit JSON tags should be true, emit prepared queries, expect queries true, and lastly emit empty slices should be true. So let's explain each line. So we have the version 2 of the configuration, then we have the Postgres engine. This line defines the path that would create our queries, and for this, the path that will create our schemas. And the name of our package will be called store inside this out directory called internal stores. All these other ones are just configuration that you can read up on. So the next thing is to create our queries and our schemas inside this migration folder. I'll come to the internals and create a new folder called migrations, like so. Then we'll create the queries.sql and schema.sql. Queries.sql and also schema.sql. So in the schema, let's create our tables. So we'll create our tables like this. Create table if not exist call it users. The ID will be of serial primary key, then username varchar, can do 255, not null, that is required, then email varchar 255, not null, password varchar not null, created. Now you want to take your time to type this thing out so that you can build your muscle memory. Copying syntax will not really help you. That is why I'm just taking my time to type it out. So we have a timestamp. We call this default. So current timestamp, then updated timestamp again. Default. Let's just use the current timestamp again. Timestamp. Then we can close this. So let's create for the blocks. To create table, if not exist, we call it blocks. Then the ID of serial primary key, title varchar 255. Then we can have the contents of varchar 255 not null, user underscore ID, this should be int, if I'm correct, int not null. Then you can also copy from here like so, then we can paste here. Then lastly we can have the relationship. So we want to do foreign key, which is the user underscore ID, should reference references users. Then we pick the ID. So it's referencing this users table here that we created, then referencing the primary key here, like so. So we have our SQLC written out. Let's head back to the documentation. So we've written out the schema. The next thing to do is to write the query. So we can use this syntax name, then you give it a method name and what is going to return. To return just a single row, you type :1. To return many, you can use this syntax called many, like so. I'll go to my queries. So I'll type name, call the name of the method called createUser, and it should return just one single row. So if I do insert into the users table, so we can pass our parameters or fields, email, password, created and updated, like so. And the values should be, can use this pattern $1, $2, $3, $4 and $5, like so. So we can returning ID, username, email, created and updated. So we can leave out the password. So we have 1 2 3 4 5, 1 2 3 4 5, like so. Then let's close this. The next thing to write is to get just one user. I'll use name, we call it get user, call it 1, like so. Then we can do select ID, username, email, created and updated, So these are the columns that we will need: the ID, username, email, created, updated, like so. Then from the users table, so where the ID equals to this parameter, the name, let's list all the users, list users, then we can type many, then select ID, username, email, created and updated from the users table. Then we can order by the ID. So that'll be all for the users table for now. Let's write for the blog table. Name, we'll call it create blog. So 1, insert into the blogs. We have title, content, user underscore ID, created and updated. So since they have the same numbers of parameters, we can borrow this from here. I'll just 15k and I'll paste it here. Then we can return in ID, title, content, user ID, created and updated. And lastly, for the blog name, you can call it list blogs. You select ID, title, content, user underscore ID, created and updated from the blogs, then order by ID, like so. Now we have the schemas created. We can create our database connection. We go to your .env. You should have your database connection in this database URL. So let me show you what we have here. Clock disable. So we have the Postgres, your username, your password, your localhost, and the database that we created earlier. So I'll split my screen and I'll go to my schema. I'll copy this command, then close this, then I will open my database client, db UI. Let's add a new connection, then we can add Postgres cyborg at localhost 5432, then REST API. Now click enter again. Now if you've added the connection, if I go to my DBUI and I do a refresh, we should have the REST API created here. Then we can paste the schema here. So and on save, if you go to your schema, you will see the blogs and the users tables created, like so. So let's close this. The next thing to do is to use the SQLC generate command. Let's head back to the documentation. SQLC generate, and this will generate the method that we'll be using with the database. So I'll open my terminal and run the SQLC generate command. We have a typo somewhere. We have Postgres. Let's go back to the SQLC. So I'll close this. It's PostgreSQL, not Postgres. So PostgreSQL. Then let's run the command again. So missing semicolon at the end of the file. Let's go into queries 22. Queries 22. So we had the semicolon. So I'll close this again, I'll run, then it means we have a success with this command. Then I'll head over to my Explorer. If I open my internal, you see it generated this folder called store, and if I open, we have the db.go, the models, and the queries. These are predefined queries generated by our SQLC, and as you can see, we have the code generated by SQLC, do not edit. With all this out of the way, we can run our program now to see if we have any error so far and if we have our app connected to the database. I'll open my terminal, clear my screen, and do go run vim-dadbod-ui. So we can see this output is coming from the ping command and server is up and running on port 8081. This brings us to the end of this section, and in the coming lesson we'll have our create, read, update and delete function. If you enjoyed this lesson, please do well to subscribe and leave a like, and I'll see you in the next one. Thank you.